Welcome to Dr. Tom Talks. Today, a special on coronavirus vaccines. With the help of the biodigital human, I'm going to be talking about all of the major players in the game. I'm talking about Pfizer, Moderna, AstraZeneca, Janssen, CanSino, Novavax, and Sinovac Coronavac. I'm going to be talking about the differences between these vaccines, how they're made, and the differences in efficacy. But first, I think it's important to understand how the coronavirus works itself and how the vaccines, all of them, work together. This is the coronavirus. It attaches via its spike proteins to the ACE2 receptor, and it's internalized into our cells. It then replicates again and again and again, hijacking the cellular mechanisms and destroying a lot of our cells, which is what ends up giving us these symptoms. And the way that every single one of these coronavirus vaccines work is that they want to create an immune response. So here's the example of coronavirus. And here are antibodies that the vaccines want to stimulate our immune system to create. And these antibodies have actually connected or bound themselves to these spike proteins on the outside of the coronavirus. And because they're bound, they're these green things right here. The coronavirus can't connect to the ACE2 receptor and be internalized into our cells and hijack them and replicate. These antibodies also tag the virus for degradation. Here's an immune cell here, and you'll see that it recognizes this virus as being foreign and ready for destruction because it's got all of these antibodies connected to it. And so it gobbles it up. So how do these various different vaccines work to elicit that immune response? Well, I'm going to start by talking about the two vaccines that have been approved in the United States, Pfizer and Moderna. These are mRNA vaccines or nucleic acid vaccines. And I'm going to show you exactly what they do. This is the coronavirus itself, or SARS-CoV-2. And then using the whiteboard function here, or the draw function, I'm going to show you what they do to create this vaccine. So here's RNA. That's the genetic material that codes for the virus when it needs to replicate. And for mRNA vaccines, what they've cleverly done is they've taken a piece, and this has never been done before in vaccines up until now. They've taken a piece of this RNA and they've taken it out and they've multiplied it and they've put it into, here's my very rudimentary drawing of a vaccine. That's the syringe right there. That's the plunger, that's the vaccine. And they put lots of copies of this genetic code, RNA, inside a vaccine. And that RNA, crucially, it codes for this spike protein right here. These are all spike proteins, these orange things around the edge. And so once that's injected into you, it encourages our cells to create the spike protein. And then you get that immune response where the body recognizes these as foreign and then creates antibodies. This is my rudimentary drawing of an antibody, which then connects to them and helps the body recognize this cell, as this virus, as foreign. And therefore in the future, it'll recognize the coronavirus as foreign straight away so that it can't attack our cells. So that's Pfizer and Moderna. And I should mention that these are about 95% effective against coronavirus. The next type of vaccine that I want to talk about are viral vector vaccines, also a very clever technology, been in existence for a little bit longer. The Ebola vaccine, for example, is a viral vector vaccine. Here we're talking about AstraZeneca, we're talking about Janssen, so J&J, and the CanSino vaccine from China. So what they do is they take a piece of genetic material from the virus, and they put it inside a much less scary virus. Here, let's draw a virus like this. This is, let's say, for example, the adenovirus, which won't do you any harm. So they put that genetic material inside the virus. And what it does is it encourages that virus to create, again, these spike proteins. And so spike proteins will be developed on the surface of that virus. And then again, you get the immune response to those spike proteins by our immune system, which then will make sure that it recognizes the virus in the future because you've already created the antibodies. Here's an antibody against those spike proteins. So those are viral vector vaccines. A couple of things. AstraZeneca has been shown to be about 70% effective against coronavirus. Janssen is one shot, and I don't think the data is out yet on its efficacy. And CanSino from China is a 79% effective. Okay, 2 down, 2 to go. Bear with me. So the third type is protein subunit. Now we're talking about Novavax here, developed in the United States, still in phase 3 clinical trials. So the data isn't out on it. And these types of vaccines have been created before, like hepatitis B vaccine, HPV, and pertussis. And what you do in this vaccine is you recreate an actual protein. So here, what Novavax have managed to do is they've recreated these spike proteins, lots and lots and lots of them. And they are, again, put into a vaccine. Again, here is my awful rudimentary drawing of a vaccine. That's the needle. Here's the vaccine itself. And they've put these spike proteins, lots and lots and lots of them, inside a vaccine. And it's injected into you. And then again, you have that immune response to these spike proteins by antibodies so that you can recognize coronavirus in the future. Finally, I want to talk about whole virus vaccines. The example of this is Sinovac's CoronaVac from China. And this is where you actually take a whole vaccine. In this case, killed vaccine. You can either have a killed or live. An example of killed vaccines that we have at the moment are flu vaccines. And the example of live vaccines that we have at the moment are like measles, mumps, and rubella, MMR. But this is a killed version of the virus, which means it can't replicate. And so you take the whole virus right here, and you kill the virus so it can't replicate, and your body has that same immune response as it would to a live coronavirus, except that you don't have all of those symptoms because it's a killed virus. So again, you have these antibodies which are created to help fight coronavirus. This particular vaccine, data just came out from its Brazil phase 3 trials. It's 50.4% effective against coronavirus, which is lower than the other ones, but it's still above that 50% mark, which is needed, for example, to approve the flu vaccine. So it's still better than nothing. Even though vaccines are in development and people are getting the vaccine, you should still practice social distancing, wearing a mask, and washing your hands, of course. For any more information on these types of vaccines and the coronavirus, please go to coronavirus.biodigital.com, where you can use this 3D interactive content yourself. This is Dr. Tom Talks, and this is a special on the coronavirus.